Good day everyone. Our topic for today is all about trigonometric substitution involving a² minus u². There are some integrals that cannot be evaluated by some simple algebraic substitution. We need to have this trigonometric substitution. We have three types, but to this video, we will discuss the integrand involving a² minus u². If you can say that a² minus u² in integral, we will try to use u is equal to a times sine of theta, that the derivative of this one is du equals a times cosine of theta, d. Let's proceed to our first problem. Our first problem, we have the integral of the square root of 9 minus x² divided by x² dx. Many times on trying how to substitute using algebraic substitution, we have hard time for it to solve using algebraic substitution. Since we have 9 minus x here, we can say that it is in the format of a² minus u². We can see that this is 3² minus x² such that our u is equal to x and a is equal to 3. According to our substitution, we will let u equal to a sine of theta. Therefore, we have is x is equal to 3 sine of theta. We have x is equal to the derivative of 3 sine of theta, which is 3 cosine of theta, d theta. So we have here x² adding term or something integral squaring this, we will have x² is equal to 9 sine squared of theta. So we need to solve the integral. We have the square root of 9 minus 9 sine squared of theta. Then don't forget dx, which is equal to 3 cosine of theta, d theta. First, we have 3 over 9 here, so this is 1/3. Then we have a common term syllable squared, which is 9. We will factor out, so this 1 minus sine squared of theta. Then we have here, this is simple sine squared of theta. Then we have cosine of theta, d theta. And take note that 1 minus sine squared of theta is actually equal to 1. Cosine squared of theta, we will replace that and evaluating the square root of 9 as 3, then 3 divided by 3 is 1. So we have 1 minus sine squared of theta is cosine squared of theta is simple cosine of theta. Rewrite again, this one is just cosine of theta is a theta square of theta. As we all know, cosine of theta divided by sine of theta is cotangent of theta. So we have cotangent square of theta, the theta, and replacing cotangent squared theta by cosecant squared theta minus 1 theta. Then the theta, then we will all know that the integral of cosine squared of theta, d theta, is negative to cotangent of theta. So this negative cotangent of theta minus theta plus c. So sine we need to go back to our original variables, which is x, and remember that we let x equal to 3 sine of theta. So we can say that sine of theta is equal to x over 3. The thing would be happen here is to draw the right triangle and then level 1 of the acute angles as theta. We will know that from our mnemonic of that sukatuwa that sine is opposite over hypotenuse. So, sine of theta is equal to opposite and x here over hypotenuse, which is 3. So, here the complete value of the legs. This must be the Pythagorean theorem. Square root of 9 minus x squared, we need here cotangent of data and cotangent of data, or since cotangent of data is adjacent square root of 9 minus x squared divided by opposite, which is x. So, this comes from this right triangle. Then, if we substitute, so we have negative cotangent of data, which is 9 minus, or the square root of 9 minus x squared over x minus the value of data here. Simple one, if you take the inverse sense of sine of this function, so this is inverse sine of x over 3. So, let us substitute it here. So, this is plus c. That will be the answer from this problem.